Hi guys, thank you for watching my previous video. Today we are looking at a new chapter called Indices, Surd, and Logarithms. So without further ado, let's turn to the next slide. So over here we have two questions, part A and part B. So we are asked to solve each of the following equation without using a calculator. So let's do part A, part 1. So we have 64 times 16 to the power of 2x equals to 1. So 64 is 4 to the power of 3, while 16 is 4 to the power of 2, while 1 is equal to 4 to the power of 0. Therefore, we have the same base 4 right now. And now what we need to do, we just need to add up the power. So left and right, we have the same base 4, and therefore 3 plus 4x equals to 0. Therefore now the question becomes very easy, and you should get x equals to minus 3 over 4, or x equals to minus 0.75. Now let's take a look at part A, part 2. Same things, you have to make the base the same. Over here, it looks like the base must be 3. So 9x is 3 to the power of 2 bracket x o minus 28 over 3 times 3 to the power of x plus 3 equals 0. Therefore over here, I can let my y equals to 3x, or 3x equals to y. Therefore I have y squared minus 28 over 3 times y plus 3 equals to 0. And now times 3 throughout, and you get 3y squared minus 28y plus 9 equals to 0. And this is a quadratic equation. So a quadratic equation, you have 3 methods to solve. You can use table method, or you can use the formula, or you use completing square. But over here, let me use the table method to solve this quadratic equation. So while I'm solving the quadratic equation using table method, so I hope you still remember the way to solve quadratic equation using table method. So I get bracket 3y minus 1 bracket y minus 9 equals to 0, and therefore my y equals to 1/3 and my y equals to 9. So when my y equals to 1/3, 3x equals to 1/3. Therefore my x is minus 1. 3x to the power of x equals to 9, x equals to 2. So I have two sets of values. Now let's come to part B of the question. So over here, let me rewrite the question down first. So as I'm writing down the question, so clearly you see they're of different base, right? So what I need to do, so all I need to do is to go ahead and solve it further. And you can see that I have simplified the given equation further. And now let me rearrange the equation. So let me park everything with power x one side, and everything with non-power x one side. So you can see that, I'm sorry, it should be 16 over 3 on the right. So I get 72 over 6 to the power x equals to 16 over 3. So 12 to the power x equals to 16 over 3. So that is the exact value of 12 to the power x. That's the answer to part B, part 1. Now let's come to part 2. Now we are asked to find the value of x. So you log both sides, and then after that you can bring down the power. So therefore you get x equals to log 16 over 3 over log 12. So take out your calculator and you should get 0.674 to 3 significant figures. Now we have come to a new question. So over here we are given the length and the breadth of a rectangle ABCD respectively, and we are asked to express in the form of a plus b square root 2 for each area of the rectangle. So what is the area of rectangle? The area of rectangle is simply length times breadth. And I hope you still remember. So I have taken the length times the breadth. And simply what I'm doing here is open the brackets. And I have got 4 terms after opening the brackets. And as you can see, I have to do something to the minus 12 over square root 2 term in order to achieve the form a plus b square root 2. So what I need to do is rationalize this term, which means I have to get rid of the square root in my denominator. So this is a way to rationalize minus 12 over square root 2. And I get minus 6 square root 2. So after that, I will just take minus 6 square root 2 and put it below here to replace my minus 12 over square root 2. And you can see I've simplified the equation further, and I'm trying to combine similar terms. 15 minus 8, I get 7, and then I get plus 4 square root 2. So this is the area in the form a plus b square root 2. So now, part 2, we are asked to find the area of the square. Given that AC is one of its sides. So in order to find the area of the square with AC as one of its sides, what I need to do here is I have to find out what is the length of my AC first. So let me draw out the triangle. So this is simply a right angle triangle in ADC. So I can use Pythagoras theorem to find the length of my AC. Remember, you can only use Pythagoras theorem when you have a right angle triangle. So over here I have a right angle triangle, so I can continue to use Pythagoras theorem. So AC squared equals to my AD square plus my DC square, which is I can take from the question. So AD is my BC, right? in fact, you can see I have switched position here, but it does not matter. So now my job is to open the brackets and see what I have got. So I have got 6 terms here, and I have one term which requires me to rationalize it, which is the minus 40 over square root 2 term. But before that, I think I can simplify it further first. Let me combine similar terms. I've combined the whole number, which I get 50. And now, let me rationalize minus 40 over square root 2. So after rationalization of minus 40 over square root 2, I get minus 20 times square root 2. So let me continue to simplify 6 square root 8, which is equal to 12 square root 2. So I replace these two terms respectively, and I get 50 minus 8 square root 2 for my AC square. And AC square is just the area of the square, so therefore I do not need to find my AC here. Now let's come to the next slide. Over here we have a log 8x equals to p, and we are asked to express log 2x in terms of p. So we have a different base for the log. So what I need to do is I have to change it to be the same base. So log 8x equals to p, I can simplify it to be log 2x over log 28 equals to p, or log 8x over log 88 equals to p. But over here we are asked to express log 2x in terms of p, therefore I choose the one on the left. So now I'm showing how do you get log 8x into log 2x over log 28. So let me continue to simplify further. So log 28, you can see is log 2 to the power 3. So therefore you get 3 in the denominator. Therefore log 2x equals to 3p. So I have found the answer for part A. So now let's go ahead and solve for part B. We are asked to find the value of k such that we are given this long equation. So you can see that we have different base for this log. Therefore our job is to try to make it the same base. So let's start with my left hand side, which is denoted by LHS. So my first term of LHS, I can simplify it to be like that. And my second term, minus log 4 bracket k minus 2, I change the base to 2. Therefore I get log 2 bracket k minus 2 over log 2, 4. So let me continue to solve for my LHS first. So my power half, I can bring it down to be in front of log 2. And the second term, log 2, 4, I get 2 in the denominator. Therefore I get half. So now I can simplify it further, because as you can see, I have both log 2, so I can take out the common factor half. And now, let me continue to do my right hand side, which is denoted by RHS. So log 4, 64, I get log 4, 4 to the power 3, minus 2 log 9, 3. So 2 log 9, 3. I can bring these 2 back to be the power of 3, right? So therefore, I get log 9, 9. And therefore, I get 3 minus 1. For my right hand side, I get 2 at the end. So my right hand side should be equal to my left hand side, right? So let me copy down my left hand side and equate it to my right hand side first. So over here, I can times 2 throughout on the left and the right, so I get 4 on my right. And now I can simplify it further, because log 2 bracket 5k plus 1 minus log 2 bracket k minus 2 equals to log 2 bracket 5k plus 1 over k minus 2 bracket equals to 4. So now my job is so much easier right now. So as you can see, 4 is also equals to log 2 to the power 4. Therefore, my 5k plus 1 over k minus 2 equals to 16. Right? So now we can cross multiply to get k equals to 3. And I have no space for C, so I have to turn to the next slide for question C. So we are asked to solve the equation log 3x minus 12 log x3 equals to 4. So log with different base, so our job is to change it to the same base. So over here, the idea is we have to change the log to be the same base. So log 3x minus 12. So now I have changed my log x3 to log 3 over log 3x equals to 4. Therefore, I can let y equals to my log 3x, and I can simplify this equation further. And let me times y on my left and on my right. So I get y squared minus 12 equals to 4y. Bring my 4y over, I get y squared minus 4y minus 12 equals to 0. And this is again a quadratic equation for us to solve. So definitely I prefer to use table method to solve my quadratic equation. So you should get bracket y minus 6 bracket y plus 2 equals to 0. Therefore your y equals to 6 or y equals to minus 2. And therefore log 3x equals to 6. And log 3x equals to minus 2. Therefore x equals to 3 to the power of 6 and x equals to 3 to the power minus 2. And therefore my x equals to 7 to 9 and my x equals to 1 over 9. And now we have come to the next question. and we are asked to sketch the graph of y equals to ln x. And by drawing a suitable straight line on the same graph, find the number of solutions of the equation x to the power of 2 times e to the power of x minus 2 equals to 1. So now let me write down the equation x squared times e to the power of x minus 2 equals to 1. So I can ln both sides. So when you ln both sides, you have to add a bracket on the left. So after that, let me open the bracket on the left. And the power I can actually bring down. So ln e is actually equals to 1. And ln 1, if you take out your calculator, you should get 0. So now let me divide by 2 on both sides. Or if you do not want to divide by 2 on both sides, you can simply bring your x minus 2 to the other side. And you get 2 minus x on the other side. So ln x is equal to 1 minus half x. And we are given y is equal to ln x. Right? So ln x is also equal to 1 minus half x. So what can we conclude here? Therefore, we can conclude that y is also equal to 1 minus half x. So this is the straight line we have to draw on the same graph. Besides, we have to sketch the graph of y equals to ln x. So let me draw the two axes first, the x and y axis. And we first draw y equals to ln x. So to draw y equals to ln x, take a look at the graphs on the right, and it should be graph 18. Because over here you can see graph y equals to log ax looks something like the graph 18 here, and y equals to ln x is also log ex. Therefore, let me draw ln x first. And this is my y equals to ln x. And next, I have to draw my y equals to 1 minus half x. So to draw this graph, we need some points. So when x is equal to 0, what do I get? So when my y equals to 0, my x equals to So when x equals to 2, my y equals to 0. And when my x equals to 0, my y is equals to 1. So actually I can plot these 2 points, and then I link these 2 points up. Let me use a straight line tool here instead of drawing it freehand. So I have drawn a straight line. Let me adjust it so that it links these 2 points perfectly. And not only this, let me darken this line as well. And extend it further. So as you can see here, y equals to ln x and y equals to 1 minus half x, they intersect at one point. And therefore, the number of solutions is 1. And let's not forget to label this straight line y equals to 1 minus half x. So we have one solution here. So that's the end of this chapter, and hope you have enjoyed it. Bye.